Hi everyone, let's now factor more exotic, general, rational, and algebraic expressions. Now, really, the principles are old school, and if you ever get confused or disoriented, just think about the old school examples. The basic principles are the same. For example, let's say we want to factor x to the fifth plus x to the third. What do we factor out? We factor out x to the third as our GCF, our greatest common factor. And why is that? Because x to the third is the power of x with the least exponent. The power of x with the least exponent. And that's a theme that we're going to apply throughout this section. To factor out the GCF, we factor out the power of x with the least exponent. So if you look at the exponents here, the 5 and the 3, the least exponent is further to the left on the real number line. 3 over here, 5 over here, 3 is further to the left, so we factor out x to the third. I'm not kidding. We're going to apply these principles later. So we factor out x to the third as our GCF. And when we factor, we do what to get the other factor? We divide. When we factor, we divide. X to the fifth divided by x to the third, right? X to the fifth divided by x to the third. When we perform that division, what do we do to the exponents when we divide powers of x? We subtract the exponents. X to the fifth divided by x to the third gives us x to the second. 5 minus 3 is 2. Another way to look at it, we start off with 5 as the exponent on x here. We're taking away 3, and the result is 2. When we divide x to the fifth by x to the third, we subtract the exponents to get the x squared. And then when we divide x to the third by itself, we get 1. If you subtract the exponents, you get 0. X to the 0 is 1. So don't forget the old school factoring. It's very instructive. Let's now factor this rational expression over the integers, z. So we only have integer coefficients. Factor x to the negative 7 plus x to the negative 4 minus 2x to the negative 1. What is the GCF here? The GCF here will be the power of x with the least exponent. We have negative 7, negative 4, and negative 1 as our exponents. Which of these three exponents is furthest to the left on the real number line? Which is the least exponent? It's going to be the negative 7. Here's negative 4, here's negative 1, but negative 7 is the least exponent. So we're going to factor out x to the negative 7 as our GCF. Negative 7 is the least exponent on x. Our GCF will be x to the negative 7. Now, when we factor, we do what D word? When we factor, we divide. And when we divide powers of x, what do we do to the exponents? We subtract them. So here's what we do. I'll go to red now. Our GCF is x to the negative 7. So we're going to factor out x to the negative 7. We're going to divide each of these three terms by x to the negative 7 to get the three terms in this other big factor. Again, when we divide powers of x, we subtract the exponents. Now for this first term in here, it's very straightforward. X to the negative 7 divided by itself, well, that's 1. Of course, x cannot be 0, but we won't worry about domain right now. X to the negative 7 divided by itself is 1. Now, what about x to the negative 4? what's x to the negative 4 divided by x to the negative 7? When we divide powers of x, we do what with the exponents? We subtract them in this order, negative 4 minus negative 7. So we get this, x to the negative 4, take away the negative 7 out here. And then for the last term, we have negative 2x to the negative 1. When we divide that by x to the negative 7, we keep the negative 2. When we divide powers of x, we do what with the exponents? Again, we subtract. We have x to the negative 1 minus, or take away, the negative 7. And then let's clean this thing up. We have the x to the negative 7, our GCF out here. And then for this 3-term factor over here, we copy the 1 plus x to the negative 4 plus 7 minus 2x to the negative 1 plus 7. When you subtract a negative number, you end up adding a positive number. When you subtract negative 7, you add 7. Then let's simplify the exponents. We have x to the negative 7. And don't forget the equal sign, by the way. A lot of students forget that. We're writing down equivalent expressions. We have x to the negative 7 times the quantity, or the factor, 1 plus x to the, well, negative 4 plus 7 is 3, minus 2x to the negative 1 plus 7 is 6. So now it's looking pretty clean. We have x to the negative 7 times the factor 1 plus x cubed minus 2x to the 6th. But now wait, we don't like to have negative exponents on x in our final answer, usually. So what can we do with the x to the negative 7? How can we rewrite this whole expression so that we no longer have negative exponents? Well, x to the negative 7 can be rewritten how? As 1 over x to the 7th. So if you take this big 3-term factor and you multiply by x to the negative 7, you're basically multiplying by 1 over x to the 7th. When you multiply by 1 over x to the 7th, you're dividing by x to the 7th. So bottom line, the x to the negative 7 as a factor up here rolls down as x to the positive 7 as a factor of a denominator. In fact, it is the denominator. This is kind of the jumping rule that we talked about earlier with laws of exponents. So we've come a long way, but we're not quite done yet. It turns out that we can do things with the numerator. Now, first of all, there are actually a couple of things about the numerator that we don't like. And different students can address these issues in different orders. What are 2 things about the numerator that we don't like? Well, aside from the fact it's 6th degree, that's another thing you don't like about it. It's 6th degree. But what are a couple of things we don't like about this guy? The way it's written. All right. A couple of things that we don't like about this guy. All right. First of all, it's not written in descending powers of x. We don't like that. A second thing we don't like is the fact that the leading coefficient, which is what here? The leading coefficient is the negative 2 here. The leading coefficient is the negative 2 here. We don't like the fact the leading coefficient is negative. In fact, let's deal with that issue first. Again, students, can deal with the descending powers issue first, can reorder the terms. But let's start by dealing with the negative leading coefficient. All right, let's start by factoring out a -1 from the numerator. When we factor a -1 out from the numerator, when we factor, we do what, D-word? We divide. So we factor out a -1, and then we divide each of these three terms by -1. When we do that, we basically flip all the signs. We take opposites. So the top becomes -1 times the factor -1 minus x cubed plus 2x to the 6th, all over the x to the 7th. Now we have basically a -1 factor up here on top. We can pop it out. So we have the opposite of the fraction. Then we have this thing here, -1 minus x cubed plus 2x to the 6th. We no longer need grouping symbols because the fraction bar automatically groups the top and the bottom. Right? So we have the opposite of the fraction, -1. See the opposite sign here comes from this negative sign. All right. So the opposite of the fraction, -1 minus x cubed plus 2x to the 6th. That was the guy in green up here. That's over here. Okay, all that over x to the 7th. Now, as I mentioned earlier, we don't like the fact that the top is still not written in descending powers of x. When we factor, we like to write things in descending powers of x. So let's reorder the terms up there. Descending powers of x. So we have the opposite of. All right. The leading term is now 2x to the 6th up on top. Then we have the opposite of x cubed, or -1x cubed in the middle. We have -1 at the back end, all over x to the 7th. Now, this top guy here may look familiar to you. 2x to the 6th minus x cubed minus 1. We actually factored that thing at the end of section 0.7. I often like to pull this kind of stunt in my notes where I refer to previous examples. So remember, this thing, although it's 6th degree, it is in what form? It is in quadratic form, because remember, the exponent up here, the 6, is twice the exponent up here, the 3. Right? And we have a constant term up here. So it turns out we can factor this thing as a QD in U, where U is x to the 3rd. Again, that substitution is optional. We factor this at the end of 0.7. All right. We started by noticing that the top can factor like so. Again, you didn't need to apply the substitution, but you can. So we get the opposite of the fraction. The top factors for now as the factor 2x cubed plus 1 times the factor x cubed minus 1. You can factor the top directly. I'll do this in green. You can factor the top directly as this factor, 2x cubed plus 1, times this factor, x cubed minus 1. If the substitution here helps factoring this thing as a QD in U, go for it. We've done that before in section 0.7. And all that goes over x to the 7th. Now remember, 2x cubed plus 1, it may not be obvious for now, but it does turn out that that guy is prime over the integers. Notice that 2x cubed is not a nice cube. So we cannot use the rule for the sum of two nice cubes here. We want integer coefficients. But this over here, x cubed minus 1, remember, we can treat that as a difference of two nice cubes. And we have a factoring rule for that. Do you remember how to apply it? I'll give you 10 seconds. All right. So in the end, and we do turn out to be done here, we get the opposite of the fraction 2x cubed plus 1, that factor, times the factor x minus 1, that's the binomial that comes from x cubed minus 1, times the trinomial factor x squared plus x plus 1. And we are following the SOAP acronym for the signs. All over x to the 7th. Don't forget that. So this is a nice way of factoring this thing up here. Over here, this in blue shading, that factors as this over here. All of this with the opposite sign in front. And in fact, you could even make this more compact, because the -1 factor indicated by this opposite sign here, we can multiply it into the x minus 1 over here, and then we can get parentheses 1 minus x. So you could say that the opposite of x minus 1 is 1 minus x. So what you could do is you could actually eliminate the opposite sign and the x minus 1 factor and replace all that with this factor here, the factor 1 minus x. But you don't have to do that. This is perfectly okay. Next up, how do we deal with fractional and potentially negative fractional exponents? Next time.